we just completed about synchronization concept. Regarding that, we just completed about synchronization concept, just a lock concept, R lock concept we covered already, right? Okay, lock concept and R lock concept we discussed already. Sir, can you please tell what is a synchronization? What is the meaning of synchronization? Anyone, can you please tell what is the meaning of synchronization? Yes, synchronization means at a time, at a time. Can I spell out? At a time, only one thread. Regarding at a time, only one thread. If only one thread is allowed to execute, then automatically we can go for synchronization concept. Sir, in Python, we can implement synchronization concept by using three ways. What is the first way, sir? Lock concept. What is the second way, sir? R lock concept. R lock concept. What is the third way, sir? Semaphore concept. Regarding what is the third way, sir? Semaphore's concept, right? Okay, like sir, lock, R lock, semaphores. Sir, we covered lock and R lock. Sir, what is the problem? The simplest way of implementing synchronization is lock concept. Regarding the simplest way of implementing, sir, is lock concept, sir. Okay, like sir, now my question here is, take a bit very special care. What is the problem with the lock concept? What is the problem with the lock concept? The biggest problem with the lock concept is lock concept can't track who is the owner, what is the recursion level. Such type of terminology not applicable to the lock concept, right? That's why if our thread calls recursive functions, if our thread called nested access to the resources, then automatically yes, this lock can't help. Regarding then compulsory we should go for what? R lock concept. What is the meaning of R, sir? Anyone, can you please tell what is the meaning of R lock? R means what? Yes, R means what? Re-entrant lock. Re-entrant lock. A thread can acquire the same lock again and again, so that the biggest advantage what we are going to get is recursive functions. If a thread is going to call recursive functions, or if a thread is going to call nested access to the resources, then automatically R lock concept is going to be very helpful for a very helpful concept, right? Okay, sir, next, who is the owner? Sir, who currently acquires the lock? Such type of information by default can able to track in the case of re-entrant lock. Remember that, sir. Okay, sir, you people should be aware clearly, right? Sir, now, sir, already lock concept is there, or lock concept is there. Why we should go for semaphore? Anyone having the idea? Can you please? Anyone having the idea, sir? When we should go for semaphore concept? In our operating system somewhere, we may have, sir, like lock concept we know, next R lock concept we know, next and after that semaphore concept. When we should go for semaphore, not for deadlock handling. Remember that it's a hardware kind of thing. No, need not be. Even it is the software component also. It is independent of language. No. Memory related lock. Semaphore. Yes. Anyone, can you please tell whatever you know? Have you ever heard about this? Because these words are, sir, almost end words. Sir, at least a basic idea we should have at least now, because we heard several times semaphores in our operating system. Next and after that, even Java synchronization. Somewhere you may heard, but can you please talk about semaphore? Unfortunately, we are not in a position. To talk about semaphore. Okay, because most of the people out of 100, 99% of the people, can you please talk about semaphore? Then automatically faced with the big question mark symbol only. Remember that it is given by OS operating system. Here I'm talking about Python language level semaphore. Okay, software related component I'm talking, not hardware. Anyone, can you please tell semaphore? Yes, suppose. Yes, legend. It's a very simple concept, sir. Synchronization concept we can achieve by using semaphore also. Synchronization concept we can achieve by using semaphore also. Then immediately you may ask, sir, lock concept we know, R lock concept we know. then when we should go for semaphore concept? Just a very simple terminology, sir. Listen a bit very carefully. How to create lock? Anyone can you please tell? How you can able to create a lock object? Yes, L is equal to lock. L is equal to lock. How to create R lock concept? L is equal to R lock. You know L is equal to R lock like this, right? Now, how a thread can acquire a lock? L dot acquire. Regarding L dot acquire. How a thread can release a lock? L dot release. L dot release like this, right? We covered already, right? So these are various API methods related to that. But now the biggest problem with the lock and unlock is was at a time only one thread is allowed to operate. At a time only one thread is allowed to operate. Okay, then we should go for lock or unlock. So sometimes my requirement is at a time only 3 threads are allowed to operate. Are you getting that? Sir, at a time only 3 threads are allowed to operate, or at a time only 2 threads are allowed to operate. Sir, my database connection, my database can be accessed by max 10 persons only. If the 11th person is coming, he has to wait. Are you getting? He has to wait. Okay. Similarly, sir, my network can be accessed by only 2 persons only. If the third person is coming, please wait some time. So my code should be executed by fixed number of threads. Remember that, sir, need not be always only one thread at a time. Sir, at a time only one thread. At a time only one thread. Then we should go for sir, lock concept or R-lock concept. But sometimes my requirement was at a time my code can be executed by 2 threads, no problem at all. Or at a time my code can be executed by 3 threads. So if you want a synchronization for fixed number of threads, regarding for fixed number of threads, then happily we can go for semaphore. Everyone can able to understand, right? Sir, what is the difference between lock concept and semaphore concept? Lock concept means at a time only one thread, but sometimes our programming requirements need not be only one thread, sir. Max 3 threads can able to operate. If the 4th thread is coming, then please wait. Are you getting? 5th thread is coming, then please wait. Like that, sir, fixed number of threads only allowed. How you can implement that concept? If you have such type of synchronization, then automatically we can go for semaphore concept. Any doubt about this one? Are you getting that? Suppose what we call chess game is there. Sir, at a time, how many members are allowed to play chess game? Assume that how many members? 2 members. Only 2 members are allowed. If the third person is coming, please wait some time. Please wait some time, because game is going on. 2 persons already started playing the game. Once this game completed, sir, then only you have to get the chance. Are you getting? So max, how many numbers are allowed? 2 members are allowed, sir. If you want such type of synchronization for a fixed number of threads, then we should go for semaphore concept. Any doubt? Everyone in a position to understand, right? What the meaning of semaphore, lock concept and semaphore? Just only one word, lock and lock. At a time, only one thread can acquire my lock. But semaphore, at a time, fixed number of threads are allowed to acquire. Okay, such type of cases we should go for lock concept, right? Best examples are here. Just have a look once, sir. In the case of lock and unlock, at a time only one thread is allowed to execute. Sometimes our programming requirement is at a time a particular number of threads are allowed to access. So like at a time 10 members are allowed to access database server, or 4 members are allowed to access network connection, etc. To handle this type of requirement, we can't use lock and unlock concepts. We should go for semaphore concept. Because why we are not allowed to use lock and unlock concept? Lock and unlock concept applicable at a time only one thread. Regarding that, okay, semaphore can be used to limit the access to the shared resources with the limited capacity. But only 4 members are allowed to access this resource at a time. 3 members are allowed to access this resource at a time. If you want to limit the number of resources, then automatically we can go for, okay, semaphore concept, right? Semaphore is an advanced synchronization mechanism. Remember that lock and unlock is nothing but normal synchronization at a time only one thread. Advanced synchronization mechanism is nothing but semaphore concept, right? Clear? Up to this, any doubt? Are you able to understand? Sir, how you can specify? The fixed number can be any number. Yes, how you can specify the number? Sir, these many number like this. Very simple, sir. I want to create semaphore object. Sir, how to create lock object? L is equal to lock like this. How to create R lock concept? L is equal to R lock like this. We created. Similarly, how you can able to create semaphore object? S is equal to semaphore. Regarding S is equal to semaphore some count value. Some count value you can specify. So this count value means how many number? Regarding count value means how many number? How many number of threads are allowed to get this semaphore? Regarding right, lock can be acquired by how many threads? Lock can be acquired by how many threads? Only one thread at a time. But semaphore can be acquired by how many threads? Sub-specified number of threads. Remember, sir, with the example, I will explain so that you people can able to understand very clearly, right? So, whenever, sir, here just S is equal to semaphore. If you are not specifying this one, then automatically, if you are not specifying this one, then automatically the default count value. The default count value is 1, sir. Remember this one. The default count value is 1. In that particular case, lock and the semaphore, both the things are always the same. Remember. So whenever thread execute acquired method, suppose assume that yes, Amit, we will discuss with the example. Why you are to worry? Just first listen the terminology. Sir, how to create semaphore? How you can able to create the semaphore? This is the base. Now S is equal to semaphore of 5 I'm taking. What is the meaning of this one? S is equal to semaphore of 5. What is the meaning of this one? Can you spell out? Respond. This semaphore can be accessed by or can be acquired by how many threads at a time? 5 threads. 5 threads at a time, sir. If one thread came, sir, one thread call yes dot acquire. Then automatically this count value will be reduced. Remember, because already one thread acquired this one, count value will be reduced. Remember, whenever thread execute acquires method, then the counter value will be decremented by 1. If a thread execute release method, then the counter value will be incremented by 1. So at a time, specified number of threads can able to get this semaphore like this, right? So acquire counter value will be, if you are calling acquire method, counter value will be decremented. If you are calling release method, automatically counter value by default will be incremented. Okay, that's all. So this is what you should aware: normal lock concept and the semaphore concept. I will go for with a small example so that you people can get clearly. Yes, up to this everyone got the basic idea. Yes, lock concept, R lock concept and the semaphore concept. What is the difference between these 3 things, right? Remember. Now my important point here is, observe that here, sir, just I'm taking case first example. S is equal to semaphore. That's all. I'm not passing any argument, right? If you are not passing any argument, this semaphore can be accessed by how many threads at a time? Remember, this semaphore can be acquired by how many threads at a time? Only one. It is exactly same as, correct? Exactly, it is exactly same as lock concept. Lock concept, right? It is exactly same as lock concept. There is no difference at all, right? Okay. Next, if I can take S is equal to semaphore. S is equal to semaphore of 3. Then automatically, can you please tell, such semaphore object can be accessed by how many threads at a time? 3 threads. How many threads at a time? 3 threads. The remaining threads have to wait until releasing the semaphore. Okay, earlier we are using the word acquired lock, release lock. Now I'm going to use the word acquired semaphore, release a semaphore. But only difference is lock and unlock can be acquired by only one thread at a time, but my semaphore can be acquired by multiple number of threads, but that number can be fixed at the beginning only. Okay, well, can I go for a small short program so that you can able to understand very clearly, right? Okay, sir, now have a look once, observe carefully about this one, sir. Okay, simple program so that you people can aware. Yes, let me open tester.py, tester.py. Okay, like I'm taking, sir. Yes, is there any tracking owner mechanism? Yes, let me check that possibility, right? Is it internally going to use lock or r lock? Is that mechanism is there or not? We will check with the example. Don't worry, sir. Here just observe that from threading import start, from threading import start. Next one after that import time out. So S is equal to semaphore, like this I'm calling, sir. Yes, S is equal to semaphore like this I'm taking. Now, can you please tell this semaphore can be accessed by how many threads at a time? Please respond. This semaphore can be acquired by how many threads at a time? Only, yes. How many threads at a time? Only one thread. Okay. Now, anyway, let me define some wish method. Wish of name I'm taking. Next, sir, yes dot acquire. Yes dot acquire. So the thread acquire the semaphore. Next, for I in range of 10. Sir, for I in range of 10. Next, I'm taking print R. Good evening. Sir, same example, whatever we covered in the last session. Good evening, comma, n is equal to empty. Because here after good evening, sir, I want to sleep for some time. Time dot sleep 2 seconds. Time dot sleep 2 seconds. 2 seconds like this I'm taking, sir. Next, after that, can you please print the name? That's all, sir. Okay, sir. Next, after completing this one, have you observed, right? After completing this, sir, how many times this for loop will be executed? Can you spell out how many times? 10 times. Once 10 times completed, then yes sir dot release. Yes sir dot release like this, right? Now that's all. This is about my function. Okay. Now I want to define multiple threads, right? Thread T1 is equal to thread of T1 is equal to thread of. Here just I'm taking, observe carefully, sir. Target is equal to wish method. Target is equal to wish method. Arcs is equal to just I'm taking some Dhoni. Okay, like this I'm taking, sir. Dhoni like that. Similarly, sir, you can take multiple threads, sir. You can create multiple threads, sir. T2, next one after that T3, like sir, T4, T5, like this I'm taking, sir. T4, T5, like this I'm taking. Sir, instead of Dhoni, yes, you can take Yuvraj, next and after that Kohli, okay, Kohli, next any other? Kohli, next and after that Rohit, next some, okay, Pandya, okay, some name, whatever I'm taking, sir. These are the people what we are taking. T1 dot start, T2 dot start, T3 dot start, T4 dot start, like this I'm taking, sir. T3, T4, next and after that T5. That's all. So this is a simple example. Sir, I want to use semaphore. A simple example I'm going to use. Now the point here is just observe that a bit carefully, sir. Sir, what is this semaphore can be accessed by how many threads at a time? Please respond. This semaphore can be accessed by how many threads at a time? How many threads at a time? Only one thread. Because you are not specifying any count value, then this wish method should be executed by, this code will be executed by only one thread at a time. Only one thread at a time. That may be any thread, we don't know. Sir, let me execute this code. Okay. Py test.py. Observe that. Only one thread. Only one thread. Dhoni is getting the chance. Once Dhoni thread completed, then the remaining threads will get the chance. Remember. Yes, once Dhoni completed, now your thread is going to come in the picture. Clear? Okay. You can add the thread name also, no problem at all. Yes, perfectly, it's going to work. No issue at all. Clear up to this, right? Any doubt? Sir, in this example, how many threads are there? Multiple threads are available. Okay, multiple threads are available. Okay, like this, right? Okay. Now, my important question here is, listen a bit carefully. All the threads are executing one by one, one by one. Regarding all the threads are executing one by one, one by one. Yes, sir. You observed the order. Yes, correct. Yuvraj, Dhoni, Yuvraj, Kohli, Rohit, and Pandya. Okay. Well, now, sir, at a time, how many threads are allowed to execute? Can you please tell? According to this example, at a time only one. Suppose if I can take two, sir. If I can take two, what the answer? Please respond. If I can take two, how many threads can execute now? My semaphore can be acquired by two threads simultaneously. Remember this one, two threads simultaneously. Sir, I have one shared resource is available. Sir, this resource can be accessed by two persons at a time. This resource can be accessed by two persons at a time. If you have such type of requirement, happily you can go for. Sir, semaphore, this is the power. If you don't want to take this argument, then happily you can go for either lock or R-lock. Now I'm taking two. Now have a look once, sir. Observe carefully. Sir, good evening, good evening. Can you please have a look one? Two threads are started or not? Yes, Dhoni and Yuvraj, only two threads executing. Both the threads executing, no problem at all. Okay, both threads are executing, no issue at all. But assume once a Dhoni thread completed, Dhoni and Yuvraj got completed. Now the next set of threads are going to start. Clear, right? Clear, right? Now Kohli and Rohit is going to come. Once Kohli and Rohit got completed, then automatically Pandya will come in the picture. So at a time, two threads are allowed to execute, no problem at all. Sir, my database can be accessed by 10 members at a time. If a 11th member is coming, hey, please wait. Internally, how I can able to implement this concept, sir? By using semaphore concept. Okay, remember. Suppose assume I don't want two, sir. I want three. Sir, at a time, three members are allowed to access. Three members are allowed to access my semaphore. Dhoni, Yuvraj, Kohli, all the three members are going to start simultaneously. Just observe that. Simultaneously. Then automatically, good evening, like this, happily it is going to get the chance. Clear, right? Everyone can able to understand? Okay, now how many threads parallelly started? Yuvraj, Kohli, Dhoni, like three threads parallelly started, sir, because my semaphore can be acquired by three threads at a time. Sir, not required to keep any explanation about this terminology. That's all. Sir, now everyone got the basic idea. What the difference between lock concept and the semaphore concept, right? Okay. Sir, this is just one small thing. Next, Raja, why you are very specific about current thread dot name? What is your intention to print the thread name here? Raja. Yes, what you want? Can we specify the threads which can run first? No. No, I'm not seeing anywhere thread priorities concept. It is running by sequence here anyway, running by sequence, but there's no guarantee. Just only by seeing 2 or 3 threads, we are concluding, okay, running by sequence, but there is no guarantee, Raja. Clear, right? Up to this? Okay. Now, sir, that's all. This is about semaphore and the lock concept. What is the difference between, what is the difference between, sir, semaphore and the lock? It's a very clear for you people, right? Yes. Means thread priority. Yeah, Omkar. I'm not seeing any thread priorities in the Python. In the Python, I'm not seeing anywhere. Just maybe this concept may be there. I'm not sure. Just go through the Google. If I will find, definitely I will tell. Okay, clear, right? Up to this, any doubt? Yes. What is the semaphore? What is the difference between semaphore and the lock concept? Next, one more extra concept is there. One more extra concept is there. Sir, for time dot sleep to function properly, we have to disable output buffering. It seems. What is the meaning of output buffering? Nandakishore. What it means? Yeah. Okay. So this is about what is the meaning? What is the difference between lock and semaphore? There is one small chota concept is there. Okay, bounded semaphore. Okay, maybe in the interview room, if any person is asking, sir, what is the normal semaphore, bounded semaphore? At least a few minutes you can able to talk. But I'm not seeing any application area where you can use this bounded semaphore concept. Just we required to do some R&D. Sir, just what is the next one, sir? Bounded semaphore concept. Okay, bounded semaphore. Just observe a bit carefully, sir. But I'm not sure where you can able to use this concept application area. I'm not seeing, sir. Just observe. So sometimes what will happen? Normal semaphore is an unlimited semaphore. Normal semaphore is an unlimited semaphore which allows to call release method any number of times to increment count value. Regarding any number of times to increment count value, right? What it means is just observe that. So S is equal to semaphore like this I give, sir. Assume semaphore of 2, sir. Yes, sir, dot acquire. Yes, sir, dot acquire. Next, one more thing I want to show. One more thing I want to show for you people. Do you know someone asked, sir, internally, is this a semaphore uses lock concept or R lock concept? Lock concept or R lock concept? I want to know. Here very simple. Here observe main thread acquires semaphore one time. Now print off main thread trying to acquire main thread trying to acquire again. Main thread trying to acquire again like this, right? Because if it is the R lock, it should be accepted. Yes, sir, done, acquired like this. Observe that. Sir, print done like this. I'm taking, sir. Just have a look once, sir. How many this S dot acquire? If it's the normal lock, internally semaphore is implemented something like lock concept, then already one time completed. Then the same thread is requesting, sorry, it can't continue, right? Now let me cross check. What will happen? Main thread trying to acquire again. Sorry, it is not getting. Means so semaphore internally uses which concepts are lock mechanism, but not R lock mechanism. Remember that it is internally uses lock. Even the same thread is coming second time. Sorry, it is not going to be. Now I have one more doubt. Here say two sir. At a time, two threads are allowed to acquire. then automatically here observe that now it should work. Now it should work. Now it should work. Observe. Main thread 1 trying to acquire, done. 1 is nothing but like. If I'm trying to acquire again, if I'm trying to acquire again, can you please tell, is it going to be accepted or not? Please respond. Is it going to be accepted or not? No, it won't accept. What is the reason? Because already one time acquired, already second time also acquired. Now you are asking third time. That's why here not possible. If you want to observe again, I'm trying to acquire. So internally, how the lock concept is implemented based on the same style. Okay, this semaphore will be implemented. Yes. No, Omkar, it is not R-lock concept. It is not R-lock concept. It is a lock concept only. Because I kept a counter at the 2, right? 2 means 2 threads are allowed to access. 2 threads are allowed to access. Main thread trying to get 2 times, then the count value by default completed. Now it is trying to acquire third time, means 3 attempts, then automatically not going to be there. So internally, semaphore is implemented something like a lock concept only. Clear? Okay. Next, there is one small chota concept, bounded semaphore. What is the meaning? What the meaning of bounded semaphore? Maybe for interview room sake I may cover, but where exactly it is going to be their application area, I'm not sure. Just go through the Google. So you know, bounded semaphore, what it means, right? Very simple terminology, sir. Sometime I'm calling s.acquire. Regarding s.acquire. 2 times completed. 2 times completed, right? Now my requirement is I'm calling s.release, like this. So how many times I acquired the lock? 2 times. But how many times I'm trying to release the lock? Okay, multiple times. Are you getting some 7 times? Multiple times. So the number of release calls may exceed number of release calls may exceed number of acquire calls. Correct or not? So no problem at all. This type of support is there in the case of normal semaphore. Remember that, sir. If it's the normal semaphore, okay, it is valid. Normal semaphore, sir, we can call release any number of times, sir. It is unlimited semaphore. Are you getting? Normal semaphore is what? Unlimited semaphore. We can call release any number of times. We won't get any error. Make sure, sir. Sir, best example. Here observe that. Sir, s.acquire. Next and after that, s.release. I'm taking s.release. Like this I'm taking, sir. S.release. Next, s.release like you're never going to get any problem at all. Happily the code is going to be valid. Yes, it's going to be executed. The number of release calls, the number of what we call acquire calls need not be same, need not be matched. No problem. Acceptable in the case of normal semaphore. That's why normal semaphore is also known as unbounded semaphore, unlimited semaphore. Okay, the number of release calls can extend the number of acquire calls. Sir, it is valid, but bounded semaphore is exactly same as semaphore, except that number of release calls should not exceed number of acquire calls. Remember that, sir. Otherwise, we will get value error. Remember, sir, what is the difference between normal semaphore and bounded semaphore? In the case of normal semaphore, the number of release calls, sir, can exceed number of acquire calls also, no problem. But in the case of bounded semaphore, the number of release calls should not exceed number of acquire calls. Remember, should not exceed number of bounded, sir, number of release calls are always bounded. Such a type of thing is called bounded semaphore. But where exactly is going to be helpful? Bounded semaphore, I'm taking, sir, all the remaining properties are always same. First, let me show with the bounded semaphore, right? Sir, S is equal to bounded semaphore. Bounded semaphore, observe that. Sir, I'm removing this. Can you please tell, is it valid or not? Please respond. Is it valid or not? According to our discussion, is it valid or not? Yes, why not? Perfectly itself is the valid, sir. Valid, no problem at all. Now, have a look once. Yes, I'm not getting any problem. Happily, the code executed and runs completed. Now, I increase yes, not release. One more call. But acquire calls are only 2. But release calls are 3. What will happen? Can you please have a look once? Value error. Semaphore released too many times. Semaphore released too many times. Like that, we are getting error. So, bounded semaphore. What is the meaning of bounded semaphore? Is the number of release calls should not exceed number of acquired calls. By mistake, if the number of release calls are going to exceed number of acquired calls, then immediately we are going to get value error. Semaphore released too many times. Clear? Are you able to get right? Sir, where we have such a type of requirement? 1 minute, sir. Yes. If anything I will identify, then I will update you. Don't worry. Sir, that's all. This is about semaphore and bounded semaphore. Clear, right? Sir, what is the purpose of semaphore? Total, can you spell out, sir? What is the purpose of semaphore? To implement synchronization in multi-threading. We have sub 3 types of mechanisms are there. Lock concept. Next and after that, R-lock concept, R-lock concept, and then semaphore concept. These are the 3 things, whatever we have related to that. Next, maybe a chance to ask the question for the interview room. What is the difference between lock and semaphore? What is the difference between lock and semaphore? At a time, lock object can be acquired by only one thread, but semaphore object can be acquired by fixed number of threads specified by counter value. Okay, like this. So that's all. Next, what is the main advantage of synchronization? Is we can overcome data inconsistency problems. But the main disadvantage of synchronization is, sir, it increases. Okay, waiting time of the threads and creates performance problems. Hence, if there is no specific requirement, don't go for synchronization concept. Lock concept or lock or semaphore concept, it increases waiting time of threads. Automatically performance effects will be there. That's why, so not recommended to use synchronization terminology if there is no specific requirement, right? That's all. Nandakishore, any limit for the counter? No. You can take some 10 or 15 and so on. No problem at all. But at the end, there should be some number based on your programming requirement. If it is the database server, then automatically 10, something like 10 default. If it is the server application server, then automatically I can use the word 60, something like there should be some number. Okay, that number itself is nothing but based on programming requirement we will decide. But officially there is no limit. Okay, like clear? Everyone in a position to understand, right? That's all. Sir, this is semaphore's concept. Now confidently you people can able to tell what is semaphore, what is the difference between lock and semaphore. Basic, at least you should be in a position to tell, array, lock and R-lock can be acquired by only one thread at a time, but semaphore can be accessed by multiple threads. But how many threads can access? Yes, only 3, only 4, only 5. We can able to specify that value, no problem at all. Okay, like sir, next concept, we are ready to go for inter-thread communication. Remember this one, sir. What is that? Inter-thread communication. Remember, inter-thread communication, right? A bit very important concept. Almost sir, a bit add on what we call advanced concepts, too much. Okay, so in general, in our Python, very specific areas, we are going to use these concepts. That's why just at least basic terminology you people should have. Yes, in Java, producer, consumer, these kind of things are there. Same terminology here also in the thread communication, right? So sometimes, yeah, the part of programming requirement. Threads are required to communicate with each other. Threads are required to communicate with each other. This thing we can implement by using inter-thread communication. Regarding inter-thread communication, some people may use, suppose two threads are there, sir. T1 is there, T2 is there. T1 will perform some updation. T2 will require that updation. Regarding T1 perform some updation, T2 require that updation. If the updation is not ready, what the T2 is always going to do, T2 has to wait. Regarding if updation is not ready, T2 has to wait. If once updation is ready, T1 is going to give the signal, hey T2, if any person waiting for this updation, can you please get this updation? Can you please get this updation? Like T1 is going to give the notification, then happily T2 is going to get in that. Sir, inter-thread communication is a very common requirement, right? Okay. So best example. Why this concept is required? Sir, very simple example, sir. Suppose assume you have to wake up early morning at 5 o'clock. Assume that, sir. You require to wake up early morning at 5 o'clock. So you went to the sleep a bit early. Early means around at 9 p.m. only you went to the sleep, because at early morning 4 or 5 you have to wake up. That's fine. So you went to the sleep a bit early, sir. Then after some time, suddenly become at 5, why you required to wake up at 5 years, you have the flight, assume that you have the flight, you require to travel to some other place. Okay, you booked the ticket, everything is ready. Early morning at 5 o'clock, you require to catch the flight. Assume yet 9 o'clock you slept. Suddenly you got woke up. Suddenly you got woke up and you checked the time, because you thought that maybe 5 o'clock. Suddenly you checked the time. Very unfortunate. 9 o'clock, 5 minutes only. 9 o'clock, 05 minutes only. Remember that. So you slept only for 5 minutes. Array, sorry. Still time is there, like you felt very happy. Then you went to the sleep. Then after some time, suddenly you got woke up and you checked the time. Then automatically 12 o'clock. 12 o'clock AM. Then you felt a bit happy. Array, still 5 more hours, happily I can sleep. 5 more hours, happily I can sleep. Like you felt and happily you slept. Suddenly after some time you got wake up. Okay. Yet you check the time, 3 o'clock, sir. You check the time, 3 o'clock it is. You slept again. Then you wake up at 3:30. Yes, you check the time, happily you slept. 4:30. Sir, you slept. Okay. Assume 4:55. Okay, still 5 more minutes I can able to sleep, like you slept, sir. Suddenly you got woke up and you check the time, morning at 9 a.m. Are you getting right? Morning at 9 a.m. What about your situation? At 5 or 6 or 6:30, you require to catch the flight. But suddenly you got wake up and you check the time, 9 a.m. Like, array, how many times you checked? How many times you checked? But whenever time is ready, but you are happily sleeping. Are you getting? Whenever you are happily sleeping. That's why if you are expecting some updation, now keep on checking is not recommended. Is not recommended. Sometimes updation is ready, you may not check, then automatically so updation may be gone. So same problem here also. So what I will do next time, what I did is I arranged one alarm. One alarm, sir. Okay. So if the time is something like I kept alarm already, sir. Assume that I kept alarm already at 5 o'clock, 5 a.m. Sir, after 9, whenever I wake up, I'm not required to check. Because if really 5 o'clock, then my alarm is going to ring or not? Yes, definitely it's going to ring, because I arranged someone to give the notification, but still I didn't get notification, means a clear indication that yes, that event not happen. Regarding that event not happen, happily you can sleep. Start sleeping, sleeping, sleeping. At sharp 5 o'clock, this alarm keep on ringing. Then you wake up and happily you can continue with whatever required things. So the point here is, if you are expecting some updation, if someone is there to give the notification, it will be too good. If no one is there to give the notification, then definitely you will be in the big trouble. Correct or not? Okay. So best example, even you know best example, sir. Uh, Assume that you require to travel to your native place. Okay, you are at a nearby city. Almost night 11:30 p.m. Last bus, only one bus is there, sir. Okay, last bus is there, only one bus is there, sir. If you miss that bus, then until early morning there is no bus. Assume that then automatically you are waiting in bus stop for your last bus purpose, but you are getting full sleeping. Then automatically what you did is, there are some more people who are waiting for the same bus. You updated to the remaining people saying, sir, I'm getting full sleep, I want to sleep. Can you please, can you, sir, whenever the bus is going to come, can you please let me know? Like you told that, you told. So then automatically, whenever bus is coming, if that person is going to intimate, array bus came, then your life will become very easy, man. Suppose if you didn't tell to any person, just you slept, suddenly you got wake up, then you check at the time 2 o'clock early morning, no one is there in the bus stop except yourself. Is it a problem or not? Observe, give it very carefully, sir. Is it a problem or not? Yes. That's why make sure if someone is there to give the notification, then our life will become very easy. So there are, if multiple threads are there, if any thread waiting for updation, for that person, someone has to give the notification. So first thread is telling, boss, I'm waiting for updation. I'm waiting for updation. Then immediately second thread is going to tell, "Oi, I performed updation. Can you please take this updation?" Like if this type of communication is there, then automatically, yes, our smooth execution of the program, even waiting time also much won't be there. Updation is ready. Immediately this person is going to get in the chance and happily can able to get. This type of thing is nothing but inter-thread communication. Clear? Clear? Best standard example for inter-thread communication is producer consumer problem. Producer consumer. Just assume that, sir, several places you may saw this producer consumer, sir, from operating system. Next several places, right? So producer will produce items to the queue. Now observe that, sir, assume that it is some queue or otherwise stack or otherwise some queue concept is there. Assume. So now producer always producing items to the queue. Remember this one. Consumer is always going to consume items from the queue, sir. Assume it is some common place, shared resource, where is going to producer will produce item, consumer is going to consume items, right? So if queue doesn't contain any items, then immediately what the consumer is going to do? Can you please tell? If the queue doesn't contain any items, what the consumer is going to do? Consumer will update, "Oi producer, I'm calling wait method. I'm calling wait method. I want to wait." No problem at all. I will wait. Once you updated, please let me know. Like this person will enter into waiting state. Now, who is expecting updation? Who is expecting updation? Consumer is expecting updation. That's why consumer will be waited. Once a producer produces the item, once a producer produces items to the queue, then immediately what the producer is going to tell, "Hey consumer, if any person waiting for this updation, this is my notification because I updated items." Like he is going to give notification. He is going to give notification. Once this first producer is going to give the notification, immediately this consumer is going to get that notification and happily he can continue with the updated items. Clear, right? So someone waiting another person notifying, giving the notification. Now the waiting person is going to get that notification, happily can able to continue. So how this type of thing is nothing but what? Inter-thread communication. Remember, in the multi-threaded applications, inter-threaded communication must be required, sir. Inter-threaded communication must be required. It's a very common requirement, right? Clear? Up to this, any doubt? Just a generalized example. Producer is only one or multiple. Next time after that, like we are not required to touch. Just observe producer, multiple producers may be there, multiple consumers are there, or only one producer, only one consumer. Based on the scenario what we are going to implement. Remember. So this is what you people should aware. So inter-thread communication is the very common requirement in our application areas, right? How you can able to do that? Okay, in Python we can implement inter-thread communication by using three ways. So three ways. What is the first way? Event. Regarding what is the first way? Event. Can you please spell out what the first one? Event. Second one, sir, condition. Second one, condition. What is the third one, sir? Queue. Okay, like this, right? What is the third concept, sir? Queue concept, right? Inter-thread communication we can implement by using three ways. The first one is nothing but event. Second one is the condition. Third one is nothing but queue concept, right? Any doubt? Any doubt? Just give away the words. That's all. Event, condition, and the queue. If you aware event, the remaining things maybe by default will become easy. That's why make sure more concentration to get basic idea of inter-thread communication. First one. If you aware first one, the remaining two things even you can ignore also, no problem at all, because this much level is not required to worry. Okay. So inter-thread communication by using, okay, what is the first approach? Can you please tell? I forgot the name. Inter-thread communication by using but the first one, sir, event like this, right? Now how we can able to do that? How we can able to do that? Sir, event, condition, queue, three things are available. Now I'm talking about event object. Event object is the simplest communication mechanism between the threads. Oh, it is a simple mechanism, simplest mechanism, simplest communication mechanism between the threads. One thread signals an event and the other threads wait for it. One thread signals an event and the other thread waits for it. What is the meaning of that? We will discuss. Don't worry. Okay. Here one word is a very important: signal and wait. Signal and wait. Best example, sir. If you want inter-thread communication, best example, traffic signal example. Can you please keep in your mind traffic signal? Suppose you are driving two-wheeler, then signal is on red. What you are going to do? Ray signal is on red. What you are going to do? You will stop. You have to wait. Then who is going to give the notification? Traffic police is going to give the notification. Oh, green is going to switch red to green. Then immediately you have to continue your execution. So the drivers, I mean vehicle drivers should require to wait. Traffic police is going to give the signal. Are you getting that? Signal. So here also the same thing. If my event object is nothing but wait, something like red, then you require to wait. If event green, something like, then automatically you require to continue. Remember that. Okay. So what it means, once we go for one small chota example, then definitely you people are going to get. Just more, please continue, please concentrate much, sir, because all these words are a bit new for most of the people, including myself also. Observe. So inter-thread communication, signaling and wait mechanism like. So how you can create event object? So very simple. E is equal to event. What is that? Can I spell out, sir? E is equal to event. Something like thread, something like lock, something like semaphore. Same way, event class. E is equal to event I created, right? So event internally manages one internal flag. Are you getting that? Event internally manages one flag. This flag can be sir, this flag can be set or can be clear. Are you getting? This flag can be set or can be clear, can be clear. So if this flag, sorry if this flag, okay, if this flag can be set or clear, if the flag is set, then automatically waiting thread can continue its execution. If the flag is clear means disable, then automatically the people should require to wait. Remember, one event object, here driver, traffic person, here assume that traffic signal is there, assume that traffic signal is there, sir. Here this is something like event. It can be enable, it can be disable. So enable means set. Disable means clear. So set means something like a green. Clear means something like a red. Remember that, something like a red. If the traffic signal, sir, is a set green, happily the drivers can able to continue. If the traffic signal clear means red, then automatically all the threads are required to wait. Observe that, sir. So event internally maintains some flag, that a flag either can set or can clear. If it is clear means disable, flag is false, disable, then the threads are required to wait. If you set, then automatically enable, then happily, sir, the threads are required to continue execution, right? Remember, sir, once we are going to this, once we convert this total theory into an example, then definitely people are going to get much clarity. But this is a topic example only I will take, so that reality you can able to see, sir. Sir, up to this, just aware chota basic terminology are you able to understand? Sir, only 3 words I'm using. But the first word, event. Event can be set or event can be clear. How to create event object? Can you please tell? E is equal to, respond man, E is equal to event. E is equal to event. Event is a class present inside threading module. Next, methods of event class. Methods of event class. So on the event object, which methods you can able to call? Sir, first method we can call set method. What the first method we can call? Set is the method, sir. So internal flag value will become true, and it represents green signal for all waiting threads. So if I call set e dot set, assume that e dot set, then automatically what will happen is, sir, my internal flag value by default will set something like a green signal, the waiting threads can able to continue its execution. Okay, like second one, sir, clear. What is the second method? Clear is the method. Okay, first one is the set method, second one is the clear method. Internal flag value will become false, that is, it represents a red signal for all waiting threads. Boss, if any waiting thread is there, sorry, don't continue, still in the red only, clear. Or green such signal to red signal, if you want to change, clear is the method you require to call. From red signal to green signal, if you want to change, then set is the method you have to call. Now I will check, is it already set or not? Is the signal, is the event object is already set or not? Yes, is set. So this method can be used whether the event is set or not. If the event is set or not, to check, then we require to use this method, sir, is set. Next, last method. Remember this one, sir. Last method, wait method. Thread can wait until event set. Or you can call wait with the time also. Boss, I will wait only this much time. Within this much time also, if the event is not going to set, sorry, I can't wait. Like this it is going to tell. Okay, thoda ఏదో అర్థమయ్యి అర్థం కానట్లు. Okay, means thoda yes, okay, like you should have, okay, like yes, obviously 50. Once you are converting into example form, then definitely you will get much clarity. Don't worry about that. Okay, so first here, sir, there is these is like acquiring the lock only, correct, acquiring the lock only. But in the case of lock, what will happen? Lock concept is applicable for shared resources. Are you getting? Omkar, lock concept is applicable for shared resources. I have one resource is there. This resource can be used by only one person at a time. Are you getting? If you want resource access, then automatically lock concept. But inter-thread communication, one person is telling boss I'm waiting, another person is telling boss updation is ready, please take that updation, like notification. That is the concept is inter-thread communication. Okay, both concepts are different, seems to be same, because they are acquire release, here also set clear, something like terminology may be similar terminology but different concepts, remember. Can I go for a small chota example? Yes, okay, yeah. Now I have one small thing. You have to tell first how to create event object. Can you please tell how you can able to create event object? Event object, E is equal to event. Okay, well, now my thread wants to wait until this event got set. My thread consumer want to wait until this event got set, then e dot wait is the method. Are you getting what is the method we require to call, sir? E dot wait is the method. The thread which is calling this e dot wait, that the thread will enter into waiting state. Until what time it will enter into waiting state? Please respond. Until what time it will enter into waiting state? Waiting state until E is set. Once E is set, then happily this thread will continue its execution. How event is can set? Can you please tell how I can set the event? E dot, what is the method? What is the method? E dot, I want to set the event. E dot set. Okay, e dot set. Once I call e dot set, now observe, assume that I am the traffic police. Sir, I want to give the green signal. Then automatically I will call which methods are e dot set. If I call e dot set, then immediately all the drivers, waiting drivers, will get updation saying boss enable already. Then happily these persons will continue execution. Sir, after 2 minutes or 3 minutes, I want to convert this green signal to red signal. Can you please tell what is the way? E dot. What is the way? E dot. I want to change from green signal to red signal. E dot clear. Are you getting? E dot clear like this, right? So the persons who are expecting updation, they have to call wait method. The persons who are performing updation, they have to call set method. Remember, next, if you want to check whether this event is set or not, anywhere e dot is set. This is another function we require to, another method we require to call. That's all. Just the same methods I repeated, so that the methods wise you are going to get some familiarity. Beyond that, nothing. Up to this, okay? Now 60 to 70%. Yes, sir, seems to be some traffic in the signal, creating event object, calling wait and set clear. Next, up to this, is it okay? Can I able to convert? Can I convert into a small chota example form? Okay. Now have a look once. Observe that, sir. What I'm taking, same terminology. From threading, import star. Next, import time. From threading, import star, import time region. Sir, I want to implement producer consumer problem. Assume that, of course, exactly same thing I'm not going to implement pseudocode. Producer consumer problem. Sir, I want to implement that scenario. Assume here P is there and the C is there. What the producer will do? Please tell. What the producer will do? Producer will produce item. Produce item. What the consumer will do? Consumer will consume item from the queue. Assume that. Sir, if this empty, if it is the empty, then automatically what the consumer is going to call? Sir, E dot wait. Regarding consumer is always going to call what? E dot wait, because event object already created, man. So consumer will wait until E is enabled, until E's flag is set. Sir, after producing items, what the producer is going to tell? E dot set. E dot set. Producer is the responsible to call E dot set, so that it is going to enable event. Now the waiting person is going to get the chance. That waiting person will continue its execution like this, right? So total, how many things are available? Can you please observe carefully, sir? Okay, sir, this code I want to convert into programmatic style. Well, here see, I'm taking DEF consumer, like this, right? Consumer thread, I'm taking, sir. Print consumer thread waiting for updation. Assume that consumer thread waiting for updation. Consumer thread waiting for updation. Like, sir, now can you please guide how the consumer thread can wait for updation? E dot wait. E dot wait like this. Sir, if you want, you can create E is equal to event, no problem at all. E dot wait. Sir, when the next line will be executed? Anyone can you please tell? When the consumer will continue next line, when the next line will be executed? If this event object is set, if event object is set by any other person, if event object set by any other person, then only he is going to continue. Means print of consumer thread got notification. Consumer thread got notification. Consumer thread got notification and consuming items. Consumer thread got notification and consuming items. That's also. Assume. Clear, right? So this is about consumer, right? Similarly, DEF producer like this I'm taking, sir. So now, anyway, let me keep some sleeping also, because producer should not produce items at the beginning. So first consumer, I want to give the chance to the consumer, because consumer should wait. That's fine. Time dot sleep of 5 seconds I'm keeping, sir. So that I'm sure always consumer is always going to get in the chance. Okay, time dot sleep. After sleep, print of producer thread producing items, producer thread producing items, sir, like this. Producer thread producing items. Next, producer thread giving notification. Producer thread giving notification by giving notification by setting event. Line. Can you please guide what is the line I have to write? I forgot the code. What is the line I have to write? Ayo, respond, man. Producer thread is going to set the event. What is the line I have to write? E dot set. That's all. Once this person call E dot set, once this person is calling E dot set, who is going to get that notification? This waiting person will get the notification. Happily, he can able to continue, right? Remember that. Now, sir, what I want to take here, two methods are there, two functions are there. Let me create two threads. T1 is equal to thread of, okay, target is equal to producer. Target is equal to producer. T2 is equal to target is equal to consumer like this. Now T1 dot start, T2 dot start. Assume that's T1 dot start, T2 dot start. Now the point is just which thread is going to start first? Please tell. T1 and T2. Assume T1 got the chance. Assume T1 got the chance. Here synchronization is not there. T1 got the chance. T1 is sleeping for some time. T1 is sleeping for some time. Meanwhile, who is going to get in the chance? T2 also. T2 consumer thread waiting for updation. Oh, this is the line 1 printed to the console. Remember, this is the line 1 printed to the console, and then consumer will wait. He can't continue because this event is not enabled, right? If it is enabled, then only it is going to be continued. Then after 5 seconds, this producer is going to wake up, and this is the line 2 is going to be printed. Sir, producer thread producing items. Next, after that, producer thread, sir, giving notification by setting event. This is the line 3. Now he is going to call e.set. Whenever this person is calling e.set, who is going to get that updation? Please observe. Who is going to get that updation? Who is waiting here? Respond. Who is waiting? Waiting here? Consumer is waiting. Then automatically, immediately, whenever this person is called set, consumer is waiting. Consumer is going to get the chance. Immediately, he is going to print this line. He is going to print this line number 4. Okay. Let me repeat again. Then you can able to understand very easily, sir. So now there are two persons are there, consumer and producer. Consumer has to wait until updation is ready. That's why consumer is calling wait method on the event object. Now consumer will enter into waiting state. Producer is responsible to produce items. After producing items, producer is going to set the event object. Once the event object is set, internally flag became green, immediately waiting consumer is going to get in the chance. Then waiting consumer can continue its execution. Consumer thread got notification and the consuming items. Any doubt? Any doubt? Okay, that's all. This is just so now at very top level, something like pseudocode we implemented. Something like pseudocode we implemented just by using printing stuff. Okay, observe very carefully about this terminology. Right now, my question is: here two threads are communicating with each other. One person is waiting, the other person is giving notification. Who is waiting? Who is waiting? Who is waiting? Consumer is waiting. Consumer is waiting. How I implemented that waiting mechanism? E.wait method. E.wait method, right? Next, who is giving notification? Who is giving notification? Producer. How I implemented that notification mechanism? E.set. Regarding E.set. So between consumer and the producer, this event object acts as traffic signal. Regarding this event object acts as traffic signal. So here, if this traffic signal is in the red, consumer will wait. If a traffic signal made as a green, consumer can continue. Who is the responsible to make this traffic signal as green? This producer is the responsible. Sir, consumer is telling, "Hey producer, I'm waiting for updation. If you are going to update, please let me know. Like that, consumer call, sir, wait method. Okay. Immediately producer is going to tell, hey consumer, if you are getting any item, if you want any item, sir, please get, because I updated. This is the notification from my side. Now updated items are ready. Then how he is going to give the notification? E dot set. Once he is calling E dot set, yes sir, this waiting person is going to get in the chance. Immediately he can able to continue. It's a execution. Thoda. Now the level 60 to 70%. 60% to 70%. Okay. Now have a look once. If we will go for one more example, then 90%. Don't worry about that. Okay. Here let me execute this code, sir. What is the output by default we are going to get? Sir, two members how they can able to talk. You can able to see that sequence in the output, sir. Observe, consumer thread waiting for updation. Waiting for updation is he want producer thread producing items, producer thread giving notification, consumer thread got notification and consuming items. Are you seeing the sequence? Yes, ma'am. Are you seeing the sequence? Yes. Okay. Observe. So whenever consumer thread call wait method, he is waiting until what time consumer will wait? Until producer giving the notification. Have you observed? Once producer thread giving notification, then only consumer thread can continue its execution. This beautiful concept is nothing but inter-thread communication by using event object. Any doubt? Here traffic signal I arrange in between consumer and producer. Sir, if the traffic signal is red, consumer will wait. If the traffic signal is the green, consumer can continue. Who is going to make the traffic signal at the green? Producer is the responsible. How the producer can do that? Okay, E dot set. Okay, how the consumer will wait? E dot wait. That's all. Okay. Some another more meaningful example. One more example, sir. We will discuss so that you people can feel comfortable. Just listen. After this example, we will go for break. Don't worry. Just let me go for a small chota example. A bit more interesting example, sir. A bit more interesting example. Just 5 minutes. Have a look once. Can I continue? Respond, man. Can I continue? Yes. Okay. Here, just 5 minutes. That's all. Same example, but with a small chota difference is there, sir. Observe carefully, sir. Sir, instead of producer consumer, now I'm taking traffic police so that you can able to understand very easily. Next, drivers, driver. Like this, there are two persons are there. One person is the traffic police. Second person is the driver. Okay, these things are same. Now, can you please guide who is responsible to call wait method? Who is the responsible to call wait method? Respond. Driver or otherwise traffic police. Driver. Hey, wait method, man. Who is the responsible to call wait method? Driver has to wait. I mean, driver means what? Traffic. What normal people, vehicle drivers. Bike. If you are going to drive, you have to wait once the signal is red. Then who is required to wait? Drivers are required to wait. Who is giving updation? Hey, you can go. Like who is going to give updation from red to green and so on? Traffic police is the responsible for that. Are you getting right? Okay, traffic police is the responsible. Traffic police is going to call which method? Anyone can you please tell? E dot. Traffic police is the responsible to call which method? E dot. Traffic police is the responsible to call which method? E dot set. Next, driver is the responsible to call which method? Driver is the responsible to call which method? E dot wait. Excellent. That's all. You have already that. Let me implement that so that you can get much clarity about this one. Okay. Now, what is my requirement is observe that. Now let me go for traffic police scenario first. Sir, DEF traffic police. DEF traffic police. Okay, here I'm taking while true because it is a continuous process. While true, it is not going to be stopped. Continuous process, right? Sir, on the road, the roadside traffic signal, it is not, sir, morning to evening. No, it is a continuous 24 hours continuous process, right? If I start this program until tomorrow also, this program keep on running. Traffic police is always keep on giving the signal. The drivers are going to wait and then continue, wait and continue, and so on. That's why infinite loop I'm going to take while of true, sir. So time dot sleep of 10 seconds. Sir, because for every 10 seconds, the signal is going to be changed. Remember that. For every 10 seconds, signal is going to be changed. That's why. So first is going to sleep for 10 seconds. Okay. After 10 seconds, sir, print of traffic police giving green signal. Traffic police, okay, giving green signal. Green signal. Okay, like a traffic police giving green signal like this, right? Okay, now just wait until completing total program. At last you can able to understand. Can you please tell what the next method I require to call? Yes, ma'am. After this line, what is the method we require to call? Please respond. After this I forgot. What is the method we require to call? E dot set. E dot set. So after giving green signal, sir, now how much time my traffic police is going to wait? Sir, 20 seconds. Assume that, sir. Okay. Time dot sleep of 20 seconds. So 20 seconds green signal I'm maintaining. Are you getting that? 20 seconds green signal I'm maintaining, right? Okay. After 20 seconds green signal, 20 seconds completed, right? 20 seconds completed. Immediately, what the traffic police is going to do? Please respond. Immediately, what the traffic police is going to do, sir? He is going to, please respond. He is going to give the red signal. Print off. Okay. Traffic police, sir, will giving red signal. Traffic police giving red signal. Giving red signal. Red signal. Okay, like this. Traffic police give a red signal. Sir, how he is going to give the red signal, sir? Please respond. What is the way? E dot? I forgot. E dot. Hey, already giving the green red signal. E dot. Further, sir, they almost out of control, it seems. Because he asked 5 minutes break, I didn't accept. Okay, E dot, what we can just E dot. What is the method? Please respond. Think a bit carefully. Is enable the signal. 20 seconds he waited. After 20 seconds waiting, you want to give the red signal. Red signal means disable. Disable means what is the method we require to call? Clear. Remember, clear. Next, this cycle will be continued, okay, forever. Remember that this cycle will be continued forever. Sir, after traffic signal giving red signal, how much time red signal will be there? 10 seconds. 10 seconds red signal, 20 seconds green signal. Are you getting? Like that I implemented. This cycle by default will be continued. Sir, observe that. So first is sleeping for 10 seconds. After that is giving the green signal. Next 20 seconds of that green signal will be there. After 20 seconds green signal, again. Okay. So he is going to disable. Disable means red signal. Now 10 seconds sleeping like that. Sir, how much time if you consider this scenario, this loop, how much time red signal will be there? Respond. How much time red signal will be there? Array, red signal, how much time? Red signal, how much time? 10 seconds. 10 seconds red signal. How much time green signal will be there? Green signal will be there how much time? 20 seconds. 20 seconds green signal will be there. 10 seconds red signal will be there. Okay, remember. Now, let me go for what the next one? Please tell. I forgot. What the next one? DEF, DEF driver function. Drivers means vehicle drivers, right? Car driver or bike driver, like. Now num is equal to 0 because I want to track how many vehicles crossing, right? Okay. Now print here, just I'm taking while of true, sir. While of true, like this. So print of drivers waiting for green signal. Drivers waiting for green signal. Drivers waiting for green signal, like this I'm taking. Then e dot wait. Regarding what is the method we require to call, sir? E dot wait. That's all. E dot wait. You know already, right? Sir, drivers waiting for green signal. E dot wait. Then when the remaining line will be executed, sir? Anyone can you please tell? If this E is set, who is going to set the E? Traffic police is going to set. If E is set, then automatically, yes, traffic signal here print of traffic signal is green. Vehicles can move. Okay, like traffic signal is green, vehicles can move, like this. Sir, only 2 lines, sir. Don't worry, it's going to be completed. Okay, traffic signal is green, vehicles can move. Next, what I'm taking is, sir, while event, sir, while E dot is set. Sir, if the event is set, if the event is set, okay, what I want to take, num is equal to num plus 1. Increment num value, print, okay, print vehicle number, okay. What that num vehicle number, num is crossing the signal, like this I'm taking, because multiple vehicles also I want vehicle number crossing the signal. Next, after this, just is sleeping for time dot sleep of 2 seconds. Time dot sleep of 2 seconds, sir. So now take a bit very special care. I have one small doubt. Observe that, sir. While true, drivers are waiting for green signal. Again, sir, first observe that after execution I will explain again. Drivers waiting for green signal, E dot wait. Now all the drivers should wait. Sir, once the signal is enabled, now the remaining, sir, traffic signal is green, sir, vehicles can move. Then automatically, while E dot is set, if the E is enabled, can you please keep on continue? Like this? Sir, this code will be continued. Sir, first num is 1. Vehicle number 1 crossing the signal. And then sleeping for 2 seconds. After 2 seconds again, num is the 2. Vehicle number 2 crossing the signal. Again, vehicle number 3. But this cycle will be repeated as long as E is set. If E is disabled, then automatically, sir, this cycle by default won't be repeated. Only 20 seconds only, this one is going to be happen. Now, print when this person is coming out from the while loop. Anyone can you please tell? When this person is coming out from the while loop, if it is disabled, correct or not? If it is disabled. Now, what I want to take? Traffic signal is red. Traffic signal is red. Drivers have to wait. Like this I'm taking. Drivers have to wait. That's all. Like this I'm taking, sir. That's all. A small application you can able to understand. Just analyze so that you can get much clarity about this one. So first let me execute so that we can able to see, sir. Observe that carefully. Sir, here how many threads are there? Please respond. How many threads are there? How many threads are there? Two threads. What the first one? Traffic police, driver. Assume traffic police got the chance. Assume traffic police got the chance first. Then traffic police, infinite loop, what is doing? Sleeping for 10 seconds. Whenever traffic police is sleeping for 10 seconds, meanwhile, driver also started. Driver, he is going to print. Drivers are waiting for green signal. Correct? E dot wait. E dot wait. Then when the next line will come, sir, traffic signal after 10 seconds, traffic signal, traffic police giving green signal. Whenever giving green signal and the set is sleeping, meanwhile, sir, these drivers are going to execute like this. 1 minute. Let me execute the scenario. Observe it very carefully, sir. Very carefully. Drivers are waiting for green signal. Traffic police will sleep 10 seconds at the beginning and is going. Yes. Drivers waiting for green signal. After 10 seconds, traffic police giving green signal. Traffic signal is green, vehicles can move. Vehicle number 1 crossing the signal. Vehicle number 2 crossing the signal. Vehicle number 3 crossing the signal. 4. As long as signal is green, it will. Once the signal is red, immediately it will be stopped. Immediately. So, traffic police giving red signal. Traffic signal is red. Drivers have to wait. Drivers are waiting for green signal. Are you getting right? Then how much time? 10 seconds. After 10 seconds, yes, traffic signal is green, vehicles can move. Vehicle number 11 crossing the signal. Vehicle number 12 crossing the signal. Like this, right? Everyone can able to understand. Okay? Who is waiting? Who is giving notification? E dot wait, E dot set. Again, 10 seconds waiting. Drivers waiting for green signal. Yes, 10 seconds completed. Traffic signal is green like that. Okay, 1 minute. Let me take here also 20 seconds. 20 seconds red, 20 seconds green. 20 seconds red, 20 seconds green. Drivers waiting for green signal. 20 seconds red. Now it is in the red color. Signal is red, signal came. After 20 seconds, traffic police is going to give the green signal. Drivers happily can continue their execution. Traffic police giving green signal. Traffic signal is green. Vehicles can move. Vehicle number 1 crossing signal. Number 2 crossing. Number 3, 4, 5, 6, 7. Like this up to 10 almost. Because 20 seconds, every time vehicle can sleep. Then traffic police giving red signal. Traffic signal is red. How much time? Can you please tell how much time red signal is there? 20. How much time? 20 seconds. 20 seconds. The people should wait. No alternative at all because the signal is red. After 20 seconds, happily they can able to continue. This cycle by default will be repeated continuously. Okay, remember that. Parthasarthi, are you there? Okay, so perfectly this one is going to be work out. Don't worry, sir. So how we can implement this inter-thread communication? Drivers, traffic police can communicate with each other. Driver thread, traffic police thread can communicate with each other by using event object. Okay, inter-thread communication we can implement by using events and then by using conditions and then we can use queues concept also. This is inter-thread communication. Yes. Which object we are using in our example? Event object we are using in our example. Maybe some other ways also there we will discuss. Don't worry about that. So this cycle by default will be continued continuously, right? Remember. Okay. Just meanwhile, just go through this example and then after a few minutes we will continue again. That's all, sir. This is about inter-thread communication by using event object. Sir, the basic idea I hope you people are aware. Sir, yesterday we covered one mechanism. We covered sir, whenever we are using sleep, it is not working properly while printing. Have you remembered, right? Have you remembered somewhere we covered this problem? Yes, yesterday, whenever we are using time dot sleep, it is not printed properly. Like yes, sir. Nanda Kishore is telling some solution from threading import star, from threading import star. What I'm taking DEF wish method I'm taking, wish of name. Okay, DEF wish of name I'm taking. Next for I in range of 10 times it's going to execute, sir. Print off, sir. Good evening. Print off good evening. Okay, like I'm taking good evening. Come on, end is equal to like this. I took next time dot sleep off, sir. 2 seconds I'm taking. Next after that I'm trying to print a name, sir. Name. That's all this is. Next import time. Import time. Okay. Now I want to sir take two threads. T1 is equal to thread R. Can you please guide? Target is equal to target is equal to wish. Next and after that arcs is equal to just Dhoni I'm taking, sir. Dhoni like this I'm taking, like sir. Similarly T2 is equal to T2 is equal to, of course, sir, lock is not required, sir. Just observe that T1. Next T1 dot start. T1 dot start like this I'm taking, sir. Sir, my requirement is if I can take like this. If I can take like this, my requirement is, sir, after printing good evening, okay, sleeping for 2 seconds, sleeping for 3 seconds. After 3 seconds, it has to print in the same line. That is it. Sir, that's about my requirement, right? Observe carefully, sir. Oh, this is a traffic signal example. Continuing. How many number of vehicles already crossed, sir? 5-10 vehicles already crossed. Observe that. 5-10 vehicles already crossed because it is infinite loop, right? Traffic signal is keep on working. How I can stop? How I can stop this one? Can I use Control C? Array, how I can stop this one? Control C. Control C is not working. Is not working. Control break. Remember that. Control break we require to take. Control break. Okay, like this we require to use. Now observe that this is the program just I'm taking here. Py test dot py. Okay, good evening. Sleeping for 3 seconds, and then good evening, and then immediately yes. Have you observed? Now sleeping we are missing. Sleeping we are missing. Good evening. Yeah. After that sleeping it has to come. So here there is one solution. One solution. Sir, flush is equal to true. Flush is equal to true. Sir, up to this whatever printed, can you please up to this whatever you want to print, can you please sir display to the console, flush. Okay, like what is the way? Can you please have a look once? Good evening, sleeping, and then good evening, sleeping, good evening, sleeping, like this, right? Yes, good, Nandakishore. Perfectly it's working. Good evening, sleeping, good evening, sleeping, like that it's going to work. Okay, so this is what is the extra attribute what you require to use. Flush is equal to true. Remember this one. So just this is there is no guarantee immediately. If you want exact behavior, then automatically we require to use flush is equal to true, like this. Sir, a beautiful. Sir, this point also you should aware, right? Okay, now let me go for inter-thread communication by using condition object. Inter-thread communication by using condition object, right? Condition object. Sir, what is the way how you can able to do that? Sir, can you please tell, in the last example we implemented inter-thread communication by using which object? By using which object? Event object. How to create event object, sir? E is equal to event, and then sir I want to set event, e dot set. I want to clear event, e dot clear. I want to wait on this event, e dot wait. Next is this e is a set or not? Okay, like this. Regarding these things you people should aware. By using these methods already we implemented, right? Sir, why don't you go for same kind of another alternative mechanism, either condition object, inter-thread communication by using condition object. Remember that, sir, condition object. How you can able to do that, sir? Sir, condition is the more advanced version of event object for inter-thread communication. Remember that, sir. Condition itself is more advanced version of event mechanism is already there. For that event advanced mechanism is nothing but condition, right? A condition represents some kind of state change in the application, like producing item, consuming item, like some state change. Condition, some kind of state change. Sir, one item produced, one item consumed, like this. Sir, this condition happened or not? This condition satisfied or not? Such type of thing is by default considered some kind of state change. Is itself is nothing but condition, right? Okay, like threads can wait for that condition. Sir, I want to wait until that condition, until that condition is going to be happen. Something like threads can wait for that condition, and the threads can be notified once that condition happen. Boss, I'm waiting until bus is coming. Once a bus is coming, once a bus came, that condition happened. Please let me know. Something like, sir, I want to wait until 2 o'clock. If 2 o'clock is coming, if 2 o'clock happen, then automatically can you please let me know? Until that particular condition happen, then I want to get notification. Then automatically we can. So this type of thing is nothing but something inter-thread communication by using what? Condition object. Okay, condition object allows one or more threads to wait until notified by another thread. Okay, inter-thread communication we can able to implement by using condition object, right? Remember, sir, one biggest specialty for condition object is condition object. Condition object is always associated with, condition object is always associated with the lock. Remember this one, sir. Condition object is always associated with lock or lock. Remember, internally condition object is going to be used or lock concept, or lock concept, right? Next, a condition has acquire method. Acquire method automatically. What the other method? Please respond. Acquire method automatically. What the other method? Acquire condition has acquire method automatically. What the other method? Release method. Regarding acquire method and the release methods are there. So a condition has acquire and release method that can call the corresponding methods of associated lock internally. So whenever on the condition object you are calling acquire, on the condition object you are calling release, internally on that lock object these methods by default are going to be called. Remember that. So we can create condition object. How you can able to do, sir? C is equal to condition. Regarding C is equal to condition, same kind of thing only. Whatever we have, E is equal to event, L is equal to lock, like C is equal to condition, like this, right? So what are various methods you can call on the condition object? Methods on the condition object. Just observe that, sir. So you can call C dot acquire. C dot acquire. Remember, sir, to acquire condition object before producing or consuming items. That is thread acquire internal lock. Boss, I'm going to do so and so activity. I'm going to acquire this condition object. The person who got condition object, okay, sir, internally he's going to get that R lock. That is the meaning, sir. Next, C dot release. We are going for examples, so don't worry about that. We will go for program. So don't worry, there you people can able to understand clearly, right? C dot release. To release condition object after producing or consuming items, thread releases internal lock. You know, right? Next, third one, sir, C dot wait. C dot wait. So to wait until notification, until getting notification. Sir, I want to wait until getting notification, sir. C dot wait off. Sometime also you can specify. So until this time expired or until getting notification, my thread is going to wait. Remember, my thread itself is going to wait until getting notification or time expired. Next, I want to give notification on this condition object. Boss, if any person waiting For this condition object updation, this is the notification. Like you can call c dot notify, you can call c dot notify all. Remember this one. C dot notify all. Okay, like this. These are the methods what you can call on condition object. Remember this one, sir. What the first method? What the first method? C dot acquire. What the second method? C dot release. Next time after that, C dot wait. C dot notify. C dot notify all. If only one waiting thread is there, then to give the notification, we can call wait method. If multiple waiting threads are there, then we require to call notify all method. Remember that. Sir, what it means? I will go for with a small example, then you people can able to understand clearly, right? Sir, in the earlier example, we used which object? In the earlier example, we used which object? Event object. Correct, right? But now onwards, instead of event object, we are going to use what? Condition object. Remember, on the condition object, which methods we can able to call? Acquire, release, wait method, notify all method. Remember that. So now the point here is the person who is expecting updation. The person who is expecting updation, he is going to call c dot wait method. Regarding the person who is expecting updation is going to call c dot wait method, then immediately thread will enter into can you spell out, sir? Thread will enter into waiting state. Observe that. So until what time? Until getting notification on this c object. Sir, c dot notify means giving notification to waiting threads. Remember that, giving notification to waiting threads. Then automatically we can go for notify mechanism. Wait method, notify method. Remember that, sir. Sir, if multiple threads are waiting, then automatically multiple consumers are there. Then automatically notify all. Remember, right? So that's all. Just give it the terminology, but how you can able to use into an example form, 1 or 2 examples, then you may get much clarity. Don't worry much about this terminology, right? Up to this, any doubt? Sir, we are performing inter-thread communication by using condition object. Which methods? How to create condition? How to get condition object? C is equal to condition. Next time after that, how many methods? Sir, which methods we can able to call on the condition object? Wait method you can call, acquire method you can call, release method you can call. Next time after that, acquire, release, next notify, all methods we can able to call. Okay, just up to this, can I expect 30 to 40%? You got the concept? 30. I'm talking about 30 to 40%. You got the concept? 30, just 30. That's all. I'm not expecting 70 or 80. 30%. Are you getting? How to create condition object, which methods you can able to call. That's all. Now slowly the links by default will be established. Don't worry about that, sir. So just a small case study we will, then automatically our knowledge level maybe a chance to increase. Don't worry about that. What is my case study is producer consumer problem. Best example to understand producer consumer problem. So the producing threads needs to acquire condition before producing item to the resource and notify the consumers. Remember that, sir. I want to produce item because I'm the producer. First I will get the condition object. First I will acquire the condition object. After acquiring the condition object, then sir I will produce the item, and after producing the item I will give the notification for all. Once I give the notification, then I will release that condition. Now that condition is available for the other waiting person. Immediately waiting person will get that condition object, and he will get notification, and he will continue something like just legend. Just observe. If I can able to convert in the coding, you can able to understand, sir. Very simple. Producer thread. Sir, here producer thread. Observe that carefully, sir. Actually, this concept is there in Java. Producer thread. So, producer thread is the responsible to produce items to the queue. Producer thread is the responsible to produce items to the queue. first generate item, generate items, sir. Okay, producer generated item, and producer thread has to add this item to the queue, add this item to the queue. But if a producer thread want to add an item to the queue, assume that he is acquiring the condition object, acquiring the condition object, oh, producer is acquiring the condition object. How we can acquire, sir? See that acquire. Once producer acquired, internally condition having lock concept, right? Now the producer got the lock of this condition, right? Now only producer can able to use this one. If the consumer is coming, definitely will wait, something like. Now what he will add the item to the resource. Okay, maybe queue, or maybe some add item to the resource, something like this. Next, after adding, producer is the responsible to give the notification. If any person waiting on this condition object, hey, if any person waiting on this condition object, this is my notification. Like producer has to give notification. See dot notify. If only one waiting person is there, see dot notify. If multiple waiting persons are there, see dot notify all. Remember that there are either notify or notify all. After giving notification, see dot release. Like this is going to come. Sir, now take a bit very special care about this one. Producer, before producing or before adding items to the queue, first he has to get the lock. I mean, he has to acquire the condition. Once producer is going to give the notification, then automatically is going to call release, something like this, right? Now consumer thread, how is going to do that? Just take a bit very special care. Consumer thread. Sir, if the consumer want to consume items, then automatically c dot acquire. Next, if items are not there, c dot wait. Next, once a producer give the notification, now the consumer is going to get that notification, then happily is going to consume item because he is getting the notification. Next, once he completed consuming item, then automatically c dot release, like this, right? So at a time, only one producer is the responsible to produce item. At a time, only one consumer is going to consume the item because of internal lock. Remember that. So just a simple pseudocode, sir. A simple pseudocode, make sure. Now let me conclude. Of course, I will convert into executable form. Very simple, sir. Producer, consumer. All two threads are there. One person is the responsible to perform updation. Another person is the responsible to get that updation. You may use producer, consumer, or you may use traffic police, driver, like any example. One person is the responsible to get updation. Another person is the responsible to provide updation and then give notification. Before performing any operation, this condition object acquired by that person. And once he acquired that, if he is performing updation, he will give the notification. So the person who is expecting updation, he will get that notification, he will acquire that lock again, and he will continue its execution like this, right? So just convert this total story into an executable code, then you people can aware. Don't get confusion. Just let me the continuation only, just I'm telling. Here see this point a bit carefully, sir. Don't worry about that. Just within a minute you can able to get clarity, I'm sure. Now can I expect 30% or 40% goes to 25%? Yes, man. 30 or 40% goes to 25%. Ayo. Yes, Manisha. Okay. Yes. Something happened on the condition. Yes. Amit, boss, on this condition something happened. Yes, this is my notification, something like that. Yeah. Yes, wait, don't worry, don't worry. 25%. Earlier I got 30, sir, 30, 35. Now I'm getting 25 only. Yes, don't worry. Just after seeing the example, suddenly the rank will goes to 70% or 80%. Don't worry. Okay, just keep on listening. Okay, now here observe that from threading import stock. Okay, like this. So now I have producer is there, consumer is there. Observe that, sir. Here C is equal to, can you please guide how I can able to create condition object? Please respond. How I can able to create condition object? You respond, man. C is equal to condition. C is equal to condition. I created. Next, two threads I want. Two threads I want. T1 is equal to thread of target is equal to consume target is equal to consumer thread, like a consume method is going to call, comma args is equal to, it is expecting some argument. Assume that I'm passing condition argument, yeah, the argument condition object, yeah, the argument. Sir, target is equal to produce args is equal to C. Like this I'm taking, sir. Total how many threads are there? Two threads are there. One is the consume method, second one is the produce method. T1 dot start, T2 dot start. Like this I'm taking. So now two threads are there. One thread calling consume method, another thread calling produce method. But these two threads to communicate with each other, I provided one condition object also. Earlier, event object acts as signal, traffic signal, event object. If the event object is red, then driver will wait. If the event object is in green color, then automatically traffic driver can continue. Here also, instead of event, now I'm using more powerful condition object, because condition object can able to talk about lock also. Internally, re-entrant lock is there. So at a time, only one person is allowed to access. Remember that. Now my question is, sir, how you can implement consume method? DEF consume, it is expecting some condition object, because I'm passing condition object as the argument, right? So now what consume is going to do that? Before consuming item, compulsory this condition object acquired by consumer, C dot acquire. Are you getting? So before consuming or before producing, compulsory some condition object must be required. Yes, I got some condition object. C dot what is going to do? Consumer waiting for updation. Pass. I got condition object, excellent. But I want I'm expecting updation on this condition object, like this. Print of consumer waiting for updation, like this I'm taking. So now, sir, he acquired the lock, and then consumer waiting for updation. So how we can call C dot wait? Remember a bit very carefully, sir. This line executed by which person? Assume consumer person. Assume consumer. Consumer thread will enter into waiting state until getting notification. Until getting notification on this C object. Are getting on this condition object. If any person is going to give the notification, then only he will continue. Remember. So after C dot wait, can you please tell when he is going to continue? Remember this one. When he is going to continue, if he is getting notification, correct or not? If he is going to get notification, then only, because once C dot wait, now thread will entered into now the thread will enter into which state, sir? Waiting state. Until what time he will be in the waiting state? Until getting the notification. Once he got the notification, print of consumer got notification. Consumer got notification and consuming the item. Consuming the item like this. I'm taking, sir. This is one another style. Okay, like, sir, once he consumed, see the release. See the release like this. I'm taking, sir. Just what the consumer acquire the condition object, and then consumer call wait method. Boss, if any person is going to update this condition object, is going to give this any signaling this condition object, please let me know. Like he's calling c dot wait. Then immediately, sir, producer is going to call c dot notify. Then this waiting person is going to get that notification like this, right? Okay, 1 minute. Let me go for produce also. Produce of C. Regarding produce of C, sir. C dot acquired. C dot acquired. Yes, because before producing, producer also should acquire this condition object. While producer producing items, no other person is allowed to use this condition object. That's why C dot acquired. Now print producer producing items. Print producer producing items. Okay, after producing items, producer giving the notification. Remember that producer giving the notification like this. I'm just taking, sir. Sir, how we can give the notification? Can you please guide? C dot notify. C dot notify. Next, after giving the notification, to continue this person, compulsory that condition must be required. That's why C dot release. C dot release like this. It's going to be happen. Now think a bit very carefully. Observe that, sir. Your knowledge level definitely is going to be raised if you are going to observe the flow. Listen this one. Sir, T1 and T2. How many threads are there? Please respond. How many threads are there? 2 threads. How many condition objects are there? How many condition objects are there? Only one condition object. Sir, now observe 2 threads. This is the condition object. This is the condition object. First thread, second thread. First thread is telling, boss, I want updation. So I will wait until this condition object giving notification like this. This person will enter. How he is going to intimate? Just he will call on this C dot wait. Regarding first thread is going to call C dot wait. Now the thread will enter into waiting state. Sir, which thread entered into waiting state? T1 thread. Assume that. So now T2 came. T2 performed some updation. After performing updation, how T2 will give the notification for the T1? Yes, they arranged already one arrangement condition. That's why immediately this T2 is going to call notify method. Immediately this person is going to call notify method. Once this person call notify method, immediately T1 will get that notification and T1 can continue its execution like this, right? Are you getting? Like now, sir, we will discuss. Don't worry. Sir, observe. Can I keep this into a small analyzation? Any layman terminology? I want to keep a small. I want to keep a small, okay, funny scenario so that you people may get. Suppose here, assume that two lovers are there. Best example to understand. Okay, lover one, I mean boy and a girl, they are in love. Assume that. So mobile phones are not there. Assume they want to communicate via land phone only. In several movies we had this type of thing. So now how these two people are going to communicate like this? They did some arrangement. What the arrangement is? Land phone is there. So this lady or gent, this one person told, I'm eagerly waiting for your call. Like this person is sir calling, wait on this telephone. Now this person is going to tell, Array, if I will give the ring 3 times. Just ring and stop, ring and stop, ring and stop. Then it's me. Happily you can pick up and you can make a call. You can receive the call. Are you able to understand, right? Okay. So this is some signaling, some signaling. So boss, this is some common object to communicate with these two persons. They have some arrangement is there. They have some arrangement is there, sir. Okay, like what this person did is, so if this person want to make a phone call to that, what is going to do? 3 times, just ring, stop, ring, stop, ring, stop. Oh, it is the notification for my friend, from my friend. Immediately, sir, she is going to get that notification. She is going to get that notification, and he can able to continue the execution. Something like, are you able to get something like? Something like, or otherwise. Okay, sir, there is one common place is there between these two. Sir, there is some common place is there, like what the hero is going to do is, heroine, hero and hero, they kept some arrangement saying, so if you are going to perform any updation, I will search here, like heroine is telling something, or hero is telling. Hero came, sir, hero came, he is going to update some letter here, and after that he is going to press the bell. Whenever he is pressing the bell, immediately this waiting person is getting notification, and he will come automatically, she will get that letter. Something like are you able to understand, right? Something like, yeah, in Telugu there is one movie is there, Bomarillu. Are you getting something like, okay, they to communicate these members, something must be required. If for that condition, okay, if for that condition sub notify, then immediately waiting person will get that notification. Okay, between these two members, what that some signaling mechanism must be required. That signaling mechanism itself is nothing but condition object. Okay, so here producer consumer, what they are going to do is, one person is consumer, another person is producer. How these people can able to communicate with each other? By using in the middle which objects are condition object. So consumer is telling, boss, I'm waiting updation. So what I will do, the persons who are expecting updation, they will call wait method on this condition object, then this person will enter into waiting state. The person who is performing updation, what he is going to do is, he will give the notification on this condition object. So on this condition object, how many people are waiting? All those people will be notified, and they will get the updations. So in the middle, in between these people, something must be required. That thing is nothing but condition object. Yes, ma'am. Good, Jaypal Reddy. Food delivery token alert. If you go to the what we call bank token alert, food token alert, like do you know what will happen is, if you go to the pizza house, or get in Domino's, then you give the order, and you are sitting. You gave the order, you are sitting. Sir, once your item is ready, immediately he is going to press the buzzer saying token number 105. Are you getting? Whenever token number 105 means, boss, your item is ready. Okay, like your item is ready. Like once you got that notification, immediately you will go there and you will get that updated item. Happily you can use that. Are you getting? Are you able to understand? Yes, man. Have you ever went for pizza house, Domino's, or otherwise any food items? Yes, Domino's pizza house somewhere, or otherwise you may have, right? So once you are going there, you paid the bill, sir, you gave the order. Then he provided slip. Sir, 10 minutes please. 10 minutes wait. Then immediately you may ask, sir, how I will notify? How I will get notification? Sir, there is one display is there. In that display, if your token number is coming, then your item is ready. Please wait for your token number, like he's going to tell. Then my eyes is always looking one side TV for whether my token is coming or not. Like I'm always looking for that. Once item is ready, token number 105, I will get notification. I will go there and then. Yes, are you in a position to visualize? Your respond, man. or am I keeping more complexity? Okay, are you in a position to visualize? Yes, sir. Now observe that. Okay, assume that. Yes, sir, assume that Partha Sarathi, he went to the pizza house. He went to the pizza house. Sir, here pizza, sir, what we call the Domino's. Okay, Domino's. The boy is there, sir. Assume that. Sir, in the middle, sir, one alert system. What we call one TV screen. TV screen is there. TV screen with buzzer. With the buzzer is there. TV screen with buzzer is there. Okay, like to get notification. Can you please tell, visualize, Partha Sarathi, this person is nothing but producer or consumer? Think a bit very carefully, don't tell wrong answer. Partha Sarathi itself is nothing but producer or consumer? Consumer, because he required. Sir, Domino's boy is nothing but the producer or consumer? Consumer. Sir, these two members should require to communicate, sir, mandatory, because once pizza is ready, he has to give the notification to Parsarde, then Parsarde will go and he will get that pizza and then happily he can eat. Okay, like that. But now the point is, how I can implement this communication mechanism? Parsarde is going to tell, yes, by taking the token, boss, I'm waiting, sir, for my token number, like he's telling, sir. Is telling like then immediately, sir, whenever Domino's sir boy he completed pizza preparation, then immediately he is giving the alert on this screen, then automatically updation is ready, then immediately Partha is going to get that updation and he will continue. Now Partha is the consumer, Domino's boy is the producer, under this TV screen with the buzzer is nothing but what is this one? Can you please tell what is this one? In our example, according to our example, what is this one? This one is nothing but condition object. Are you getting? Condition object. Assume that on this condition object, Pardasarthi is going to call which method? Wait method. Pardasarthi is calling wait method. And sir, this Domino's boy is going to call which method? Notify method. So to communicate with the two persons, okay, some mechanism must be required. That mechanism is nothing but inter-thread communication. In that one mechanism is condition object. Thoda our knowledge got raised at least 40 to 50. Now you may tell, sir, already time is 8:30. That's why you may. Yeah. Okay, I hope it's a very clear for you people, right? Remember that. Yeah. Okay. Why, sir? Here we require to wait and signal. If a producer releases the lock, then consumer will get it. Because the reason for that is it may be. So while producer producing the items, the consumer should not allowed to get. Are you getting? Should not consumer is not allowed to use. While consumer consuming the items, producer should not require to perform updation, something like at a time, either consumer or producer, only one person should use, something like that. This condition object can be acquired by at a time either producer or consumer, like that. Are you getting right? Not getting. Producer releases luck, but sir, acquire and the releases are there. Onkar, I didn't get it. Yes. So why will take care? So why wait and signal? These things are required. Yes. Here just observe. He acquired the lock, and then he's calling wait method. Now this person entering into the waiting state. Sir, when this person will continue again, whenever some person is going to give the signal. Are you getting? If he's not going to give the signal, then he can't continue, right? Okay. To signaling mechanism is nothing but notify must be required. Remember that notify must be required. Okay, pure lock concept is at a time only one thread. But how you can able to tell, boss, this is my notification, This is I'm waiting, like for that this wait and notify must be required. Yeah. Yes, just observe a bit very carefully, sir. Let me execute this code first. Let me trace and then we will discuss about this. Here, see this one. Sir, here two threads are started. Assume consumer thread got the chance first. Consumer acquired the lock. Assume consumer thread got the chance, consumer acquired the lock. Consumer acquired the lock. Now, first line it is going to print consumer waiting for updation. Sir, this is the line number 1. Consumer waiting for updation, line number 1. Next, C dot wait. Now the consumer will entering into waiting state. If the consumer entered into waiting state, then immediately producer is going to get that lock. Because if C dot wait, lock will be released, C dot acquire. Producer got the lock. Producer producing the items. Regarding producer producing the items, line number 2. Okay, producer giving the notification, line number 3. Line number 3. Next, producer giving notification. Yes, consumer got that. Producer releases a lock. Once a producer releases a lock, then consumer got the notification and the lock also. Consumer got notification and consuming the items. Line number 4. Okay, line number 4. And then he releases like this, right? So now observe a bit very carefully about this one. Yes, okay. Can you please have a look once? Consumer waiting for updation. Producer producing items. Producer giving notification. Consumer got the notification and consuming items. Can you please have a look once? Can you please observe that? Consumer waiting for updation. Sir, now he is entering into waiting state. He is entering into waiting state. Now producer producing the items. Producer giving notification. Once giving the notification, then only consumer got that notification and the consumer is right. Sir, have you observed, right? Two persons can communicate with each other. You can able to see some sequence of operations, right? Which is nothing but inter-thread communication. Remember. Yes. Any doubt? Lot of doubts. Not getting that much clarity. Okay. One. Don't worry. Just I will go for another small chota example. I mean same example, a bit more detail so that you may get the clarity. Just wait for a minute, sir. I will go for one more example. One more example, right? So that you may get the clarity. Still after that also, yeah. Atul, what's your doubt? C dot release. At which line you are talking? At line number 14. Correct, right? Atul, at line number 14. Yes. If you are not going to release the lock, then the waiting thread, the waiting consumer should continuously waiting only. Should continuously waiting only. Okay. Yeah. Vijaya. C dot acquire can execute simultaneously without releasing. C dot acquire, this line should be executed by only one thread, because the reason is the thread trying to acquire the lock. Okay, that's why at a time how many locks are available? Only one R lock. Getting? Yeah, let me, Onkar, we will do that. First, observe, let me go for one more small example. Just I'm saving for your reference. Just 1 minute. I may use this code later. Just let me go for one more example. and then we will, sir, is there any chance to get some clarity? Yes, have a look once, sir. Yes, same example with some more extra things I'm going to explain. Just observe, at least now you may get. So now I'm taking from threading import star. Next, and after the import time I'm taking import time. Next, import random. Are you getting? Just the three modules, sir. Observe that three modules: training module, time module, and a random module. Like this, I'm taking. One items is equal to like this. Sir, what is this one? Respond. What is this one? Items is equal to square bracket open and close. What is this concept? List concept, right? Sir, for which purpose? Same example only, I told, right? Sir, producer always producing the items to the list. Consumer is always going to consume items from the list. Remember that in the middle, I kept list. I kept a list also. Okay. Now, sir, DEF produce. Same. Produce of condition object. Sir, producer want to produce items. Sir, while true, C dot acquire. While true, C dot acquire. Sir, condition acquired by producer thread. Condition acquired by producer thread. So now, what the producer has to do? He will generate some random number and producing that item, adding that item to the items. Okay, like what I'm taking is item is equal to random item is equal to random. Here just take a bit special care. Item is equal to random dot rand int. Random dot rand int. Rand int. Have you observed, right? Rand int method is there 1 to 100. In between 1 to 100, randomly, can you please generate some number? Can you please generate some number? Print producer producing the item. Producer producing the item. Producer producing the item. Just I'm trying to print that item value. Okay, well, now I'm trying to print that item, right? Producer producing the item. Just a matter of few minutes, please. You may get the clarity. Otherwise, sir, I will simplify. Maybe in what way you can able to understand. I will do some work and then I will keep. Just try to understand. Sir, item, producer producing the item. Next, I want to add this item to the items. Items dot append of this item. Now I added generated item to the items list. Okay, like next, producer giving notification. Print of producer giving notification. Like this I'm taking, sir. Print of producer giving notification. Sir, can you please tell how you can able to do that? How you can able to, how the producer can give the notification? C dot notify, and then C dot release, release also. Just I'm taking some time dot sleep also 5 seconds. Just wait. What is the need? I will explain at last. Just observe that. So that's all. What the producer is always going to do is very simple, sir. Very simple. He acquired the lock object. He acquired the lock condition object, and then generated some random number in between 1 and 100. Printed that to the console and added to the list. Producer giving the notification, notify, release, and then is sleeping. So here 5 seconds is going to sleep. So that meanwhile the consumer is going to get. Now DEF. Okay, what is the next person? Please respond. What is the next person? Yo, respond, man. What is the next person? Consumer. Okay, consume. Like I'm taking, sir. Consumer of C. Consumer of C. Now It is also continuous process. While true, while true. What is the first one, sir? C dot acquire. C dot acquire. Okay. C dot acquire. E got the condition object. Print consumer waiting. Consumer waiting for updation. Consumer waiting for updation. Updation like this I'm taking. Consumer waiting for updation. Sir, can you please guide what he has to do? C dot wait. C dot wait. Next, sir, when he is going to get the when this line will be continued? Anyone can you please tell when the next line will be continued, sir? Once he got the notification. Print of consumer. Print of consumed item. Sir, what that item? Consuming the item. How we can able to consume the items are very simple. Can you please guide how we can able to consume the item? Items dot pop some random value by default is going to get, sir. And then C dot release. After that, time dot sleep off 5 seconds something. Okay, just producer after performing updation is giving the notification. Consumer, sir, before consuming is calling wait method like this, right? Now C is equal to condition object under T1 is equal to thread of target is equal to consume. Target is equal to consume. Args is equal to, okay, what is that? C like this. Same way, target is equal to produce and args is equal to like this. Next, T1 dot start and then T2 dot start. Now, have a look once, sir. Almost the same code only. How it is going to work? First, observe that. Have a look once. Consumer waiting for updation. Producer producing the item 90. Producer giving notification. Consumer consuming the item 90. Producer giving the item 7. Producer giving the notification. Consumer waiting. Are you getting right? So this cycle by default will be repeated. Observe that because pop method I use it. Randomly it is going to select some number. There is no guarantee every time is going to get. So from that some number it is going to be sir, producer producing 7, but still consumer not getting that 7. Are you getting randomly? Okay. So something like